Okay, I thought I'd just do some of the questions that you made up today in class. So there's 5 questions that made up, and let me just see if I can make them solve them. So the first one says propane tank barbecue, volume of that, and maybe I'll just do my P1, V1, T1, N1, and see what I have here. So I have a volume of 23.4 liters, and the pressure's at 2.4 atmospheres. And the temperature is 22.4 degrees Celsius. So that's 273.15 plus 22.4. So I have to figure that out. And then they say what mass of propane. So to get the mass, I'm going to have to first figure out moles. Okay, let me add this together. So that'd be 295.55 Kelvin. And then this atmosphere is no good. I need kilopascals, right? So 101.325 kilopascals is the same as 1 atmosphere. So if I multiply those two, I should get my kilopascals. So 2.4 times 1.325 divide 1. So 243.18 kilopascals. Okay, good. So let's use our formula. PV equals nRT. I'm looking for N. So N will be equal to, and careful with this, PV is on the side on its own, so that has to go on top. The ones that I'm dividing by to get rid of will go on the bottom. So the pressure, 243.18 kilopascals, times the volume, 23.4 liters, divided by R, 8.314 kilopascal liters per Kelvin mole, and times, what else do I need? T, 295.55 Kelvin. Kilopascals, liters go, kelvins go, left with moles. Good. And I have moles. They say mass. I'm going to have to figure out that mass stuff later, but let me get this one first. Okay, so I have that, the pressure times the volume, divided by, in brackets, 8.314 times 295.55 in my bracket. So this tells me I have 2.3158 moles of propane, which is C3H8. So now my next step then is to figure out the mass. So I know that moles are equal to mass over molar mass. So to figure out mass, it's going to be moles times molar mass. So the moles are 2.3158 moles times the molar mass of propane. Okay, 3 carbons will give me 36.03, and 8 hydrogens is 8.08. So that'll be 44.11. So 44.11 grams per mole. Moles cancel out. So the mass is equal to, I take that number that's in my calculator and I go times 44.11. So in my propane tank, I have 102.15 grams of propane. Now let's look at sig figs. 2.4 atmospheres, that's only 2 sig figs, so I can only give 2 sig figs in my answer. Ooh, this could be hard. I can't go 102 grams because that's 3 sig figs. And I can't go 100 grams because that's only 1 sig fig. I guess I'll have to do scientific notation. So I could go 1.0 times 10 to the 2 grams. That'd be 2 sig figs. I guess I could convert it to kilograms. So I could call it 0.10215 kilograms. But that's 4 sig figs, right? So to do it as just 2, it'd be 0.10 kilograms. That'd be 2 sig figs too. So this one would be good. This one would be good too. All right, here's a good one. What pressure? Oh, grams. You're going to have to convert that to moles. Temperature 21 and volume of 5. Okay, so PVT moles. I'm not changing any of those, and so it's just going to be the ideal gas law. Pressure they're looking for. Volume they give me is 5 liters. Temperatures, okay, 273.15 plus 21. So that's 294.15 Kelvin. Number of moles, I don't know, but it's mass over molar mass. So mass is 2 grams divided by oxygen is O2. Oxygen is 16, and 2 of them, that'd be 32 grams per mole. Grams cancel. If you divide that, it comes out to this many moles. Okay, I think I'm ready. So my formula, PV equals nRT. So I'm looking for pressure. So it's nRT divided by V. Moles, 0.0625 moles. Universal gas constant, 8.314 kilopascal liters per Kelvin mole. What do we need? Temperature, 294.15 Kelvin, and the volume is 5 liters. Okay, moles cancel, liters cancel, Kelvins cancel, left with kilopascals. Life is good. Okay, let's plug all that stuff in. So 0.0625 times 8.314 times 294.15 divided by volume of 5. So I'm getting 30.5695 kilopascals. 3 sig figs everywhere. So I need 3 sig figs. So 30.6 kilopascals. Determine the pressure inside a pop can with a volume of 0.355 and that many moles of CO2 at room temperature. Okay, so pressure, oh, that's what I need to figure out. Volume, 0.355 liters, and that's exactly the volume of a pop can. Temperature, 21 Celsius, so 273. So that, I wonder if I figured that other one out wrong. Whatever. 21. So it'd be 294.15 Kelvin. And the number of moles, I have 0.721 moles. Good. Don't need to convert anything, so I'm good. Off I go with PV equals nRT. So P is equal to the moles, I'll write it out, divided by the volume. So the mole is 0.721 moles times 8.314 kilopascal liters per Kelvin mole times the temperature, 294.15 Kelvin, divided by the volume, 0.355 liters. Moles, liters cancel, Kelvins cancel, left with kilopascals. This is good. Okay, calculator. 0.721 times 8.314 times 294.15 divided by 0.355. So I'm getting 4,966.9 kilopascals. Looks like I gotta go to 2 sig figs. So, So this one has to go up, so it would have to be 50. I'm going to have to do sig fig or scientific notation with this one too. I'm going to have to go 5.0 times 10 to the third kilopascals. You could change the kilopascals to megapascals. So you could write it as 5.0 megapascals, but probably that's preferred. Okay, here's another similar one. So I'm not changing any conditions. They just want to know how many moles of helium this thing contains. So pressure, volume, temperature, moles. Pressure, it's STP, and by definition our STP at, or our standard temperature and pressure, the standard pressure, I'm just looking off my chart, here is 100 kilopascals. So it's 100.00 kilopascals. Volume is 94 mils, so let's convert that to a liter, 94 liters. The temperature at STP is 273.15, and moles is what I'm looking for. So my formula, PV equals nRT, I'm looking for N. So N is going to be equal to PV over RT. So the pressure is 100 kilopascals times the volume, 0.094 liters, divided by universal gas constant, 8.314 kilopascal liters per Kelvin mole. And the temperature is 273.15 Kelvin. Kelvins go, liters go, kilopascals go, moles are what I'm looking for. Good. This is one where you want to use your brackets on your calculator. So 100 times 0.094 divided by bracket 8.314 times 273.15, end my bracket, go. So the moles are 0.004139 moles of helium. Now let's look at sig figs. 2 sig figs there. STP would have more than 2, so I need to go limit it to 2. So my sig figs will be 0.0041 moles. That's with 2 sig figs. Okay, one last question. What's the volume of, volume, pressure, temperature, moles. So they want to know volume. Moles, they give me 1.49 moles, and it's nitrogen. Needed to get 15 psi, so the pressure is 15 psi. So I need to fix that. So it's 14.69 psi is the same as 101.325 kilopascals. Okay, so I can figure that out. Then the temperature is 25 Celsius. So add my 273, that I think gives me 298.15 Kelvin. Again, it's all just properties, so I'm not using a Charles Boyle's law, any of those. I'm using the ideal gas law. So PV equals nRT. I'm looking for volume. Moles, 1.49 moles. Universal gas constant, 8.314 kilopascal liters per Kelvin mole. Temperature, 298.15 Kelvin. And then the pressure, I've got to figure that out. It's going to be 101, it'll be close to that. So 15 times 0.325 divide 14.69. So 103.4632, etc. And that's my pressure, 103.4632 kilopascals. Kilopascals go, kelvins go, moles go. I'm left with liters perfect. Okay, so 1.49 times 8.314 times 298.15 divided by that other number, and I get 35.69809 liters. Sig figs, I got 3 there, 2 and 2, so I got to go to 2. So that'll be an even 36 liters. So that would be the volume of 1.49 moles of nitrogen gas needed to get 15 psi at 25 degrees Celsius. Okay, hopefully that helps you with those questions.